Alternating current. Alternating current, in short, AC, is a type of electrical current in which the flow of electric charge periodically reverses direction. Now we know that in case of AC, it is alternating. That means its charges, electric charges, periodically reverses the direction. One time positive and second time negative likewise. In contrast to direct current, DC, where the electric charge flows in one direction. In case of DC, we know that the electric charge flows in only one direction. AC is the form of electric power that is delivered to businesses and residences. And we know that mostly the power used is AC, which is supplied to or delivered to businesses and residences. It is the form of electrical energy that consumers typically use when they plug kitchen appliances, televisions, fans, and electric lamps into a wall socket. So, as we all know that kitchen appliances, televisions, fans, and electric lamps, these are all runs on AC, that is alternating current. Now let's see the key characteristics of AC. Waveform. The most common waveform of AC is the sine wave. So we know that sine wave is like this. This is a sine wave. The most common waveform of AC is the sine wave. Other waveforms can be include square wave and triangular waves depending on the application. So it may be sine wave, triangular wave or square wave, but it will be of same pattern, one time positive and second time negative likewise. Then frequency. The frequency of AC is the number of cycles per second. From here, this 0 to this part, it is one complete cycle. And how many cycles completed in 1 second is called as frequency. And its unit is Hertz, which is represented by Hz. In most of the world, the standard frequency is 50 Hz. So different country uses different frequencies. While in the US, that is United States, it is 60 Hz. Then next is amplitude. This refers to the peak value of the voltage or current. So here we can see, here the peak value is, this. This is the peak value. So this will be the amplitude. It will be the amplitude. This refers to the peak value of the voltage or current in household power systems. The standard voltage amplitude varies by country, typically 120 volt or 230 volt. Then next is phase. AC can have multiple phases. Single phase power is the standard in residential settings, while 3-phase power is common in industrial and large commercial settings due to its efficiency in power distribution. So AC supply is of single phase or of 3-phase. Then advantages of AC. So it have efficient transmission. AC is preferred for power transmission over long distances because it can be easily transformed to different voltages using transformers. So we can transform the AC, but we cannot transform DC. High voltages are used to reduce energy losses over long distances. So here we can transmit AC by using transformer and transmission lines. We increase the voltage and decrease the current. So by decreasing the current, we increase its efficiency and reduce its energy losses. Otherwise, what happened? If the current is more in transmission line, then due to heat, there will be more losses. So to avoid this, we increase the voltage and reduce the current. So this is done with the help of transformer, and it can be used in only AC. Then next is generation and distribution. AC power generation is simpler and more cost effective compared to DC. So we know that the generation of AC is very easy. We can generate alternating current with the help of alternator. AC generators or alternators are robust and require less maintenance. Then usage in induction motor. As we know that mostly 80% of the motor is induction motor. So AC is suitable for running electric motors used in various household appliances and industrial machinery due to its ability to create rotatory magnetic fields. So this is done with the help of 3-phase or single phase also. Then next is applications of AC. Now applications of AC is domestic power supply. Most household electric devices operate on AC. As we know that in our homes we use AC supply. Then industrial power systems. Factories and industrial plants use 3-phase AC for heavy machinery and equipment. Then lighting systems. AC is used for street lighting, home lighting and commercial lighting systems. Then HVAC, high voltage AC system, heating, ventilation and air conditioning systems predominantly use AC. So these are the application of alternating current. Then if we compare this with DC, comparison with DC. Direction of flow. AC reverses direction periodically, while DC flows in one direction. Then transmission efficiency. AC can be transmitted over long distances with less loss compared to DC, thanks to the ease of voltage transformation, which can be done with the help of transformer. Then complexity and cost. AC systems are generally less complex and cheaper to operate and maintain than DC systems for large scale power distribution. We know that AC is cheaper than DC. Then historical context. The development of AC power systems was pioneered by Nikola Tesla and George Westinghouse, which led to the famous War of Currents with Thomas Edison, who advocated for DC. The superior transmission capabilities and ease of voltage transformation of AC eventually made it the dominant form of electrical power distribution. So finally, we use the AC supply. Then conclusion, alternating current is the backbone of modern electrical power systems, providing efficient and reliable energy for residential, commercial and industrial applications. Its ability to be transformed to different voltages for efficient long distance transmission makes it indispensable in today's energy infrastructure. So this is about the alternating current.